Hello everyone, today we are learning extraction of aluminium. This is another important topic of IGCSE Chemistry. Now before starting, we should know that the main ore of aluminium is bauxite, and when it is purified, it gives you alumina. When purification is done, it gives you alumina, which has a chemical formula of Al2O3. Now to extract aluminium from Al2O3, we need to reduce it. Now reduction can be done using two methods. One is carbon or carbon monoxide reduction, and the second one is electrolytic reduction. Now why aluminium is electrolytically reduced? Because in the reactivity series, aluminium lies above carbon, and that's why aluminium is more reactive than carbon. So that's why we have to use electrolytic method for reduction. Now, the main problem with the electrolytic method is that alumina has a very high melting point, which is around 2050 degrees Celsius. At this melting point, a lot of energy is consumed and it is not economical. Now, to make it economical, we use cryolite, which is Na3Al(F6). Now, cryolite has two functions in aluminium extraction. First function is it decreases the melting point of the mixture. Melting point of mixture. And the second is it increases the conductivity. So for electrolytic reduction or electrolysis, a good conducting electrolyte is very useful. So it increases the conductivity. Now let's look at the electrolytic cell. These are the positive carbon anodes. We use multiple anodes. We'll tell you the reason why. So this is carbon anodes. Basically, it is positively charged. And this is negative carbon cathode. The blue lining, which is the negative carbon cathode. So anodes as well as cathode is made up of carbon. And the electrolyte is a mixture of alumina and cryolite. Now, as the process starts, the reaction at cathode, we know, is a reduction reaction, and the reaction at anode is oxidation reaction. Reduction is gain of electrons. This is gain of electrons, and this is loss of electrons. If you look at the reaction at cathode, this is now aluminium is Al3 plus gains electrons and it is deposited at the bottom because the full of lining is made up of carbon cathode. So if we write the reaction at cathode, it is Al3 plus will gain 3 electron and forms aluminium. So this reaction occurs at cathode, and at anode the reaction will be oxygen will form O2 plus, if you balance it, there will be 4 electrons lost. Now, you will see that there are bubbles of oxygen gas evolved at the anode. Now, so as I was saying that we use multiple anodes here because anode is made up of carbon, and due to a very high temperature, see, cryolite decreases the melting point, but this decrease in melting point is around 950 degrees Celsius, which is again a very high temperature. So at a very high temperature, the oxygen gas, which is evolved, reacts with the carbon of the anodes. And when the carbon of the anodes is reacted with oxygen, it forms carbon dioxide and sometimes carbon monoxide that consumes the anodes. So to make the process continuous, we use multiple anodes so that the process goes on for a longer time. So we can also write that the carbon of the anode reacts with the oxygen to produce carbon dioxide, sometimes carbon monoxide. Now, I hope you have understood the extraction of aluminium. This is a very important topic, and from past years, the questions are coming from this topic. Thank you so much.